Welcome students, myself Kale, Rayat Shikshan Sanstha's RBNB College Rampur. 11 Science Mathematics Part 2, Lecture number 12, 7th topic Limits, Exercise 7.6. In the previous video lecture, we have completed question number 1st of Exercise 7.6, which depends upon limits of exponential function and logarithmic function. Today we start here question number 2nd. So let us see here. Question number 2nd, evaluate the following limits, and first problem is limit x tends to the 0, 3 to the power x plus 3 to the power minus x minus 2 upon x tan x. Now if we put here x as a 0, denominator becomes 0, so we have to solve this problem by using any method. So solution of this is equal to limit as x tends to the 0, this 3 to the power x as it is, we write this 3 to the power minus x as 1 upon 3 to the power x using the rule of indices. A to the power minus x, that is equal to 1 upon a to the power x. This minus 2 as it is and divided by x tan x. Now here this 3 to the power x is in the denominator, we have to cancel this, so we multiply by 3 to the power x to numerator and denominator. So we get this is equal to limit as x tends to the 0 multiply by 3 to the power x. So 3 to the power x into 3 to the power x, so 3 to the power x bracket square plus 3 to the power x into this 1 upon 3 to the power x, 3 to the power x get cancelled, so here plus 1, and minus 2 into 3 to the power x divided by, here also multiply by 3 to the power x, so 3 to the power x into x tan x. So this is equal to limit as x tends to the 0. Now observe the numerator. We write this numerator as 3 to the power x bracket square, write this minus 2 3 to the power x here, minus 2 into 3 to the power x and plus 1, this plus 1. We may write this 1 as 1 square and divided by 3 to the power x into x tan x. And now here observe numerator. Here a square minus twice a into, suppose here b, that is 1, plus b square, that means numerator is a minus b bracket square. So using the formula a minus b bracket square, we get here it is equal to limit as x tends to the 0, 3 to the power x, here middle sign is minus, 3 to the power x minus 1 bracket square. If we expand this 3 to the power x minus 1 bracket square, we get this, that is 3 to the power x bracket square minus 2 into 3 to the power x into 1 minus 2 to 3 to the power x and plus 1 square divided by 3 to the power x into x tan x. Now here we know the formula, a to the power x minus 1 upon x limit as x tends to the 0, this is equal to log of a. Okay, so power x divided by x, we must have, if a to the power x, then this power x should be in the denominator. Here 3 to the power x and divided by x, we want here divided by x, but here bracket square, so divide by x square. So divide the numerator and denominator by x square. So we get limit as x tends to the 0, 3 to the power x minus 1 upon x square and divided by this 3 to the power x into x tan x upon x square, means we divide numerator by x square and denominator by x square. Okay, so now this x and x get cancelled, so we now take this limit to numerator and denominator separate. So limit as x tends to the 0, here numerator square upon denominator square, we write numerator upon denominator bracket square, that means 3 to the power x minus 1 upon x bracket square, and then take this round bracket from this limit, take limit inside the bracket, and in the denominator limit as x tends to the 0, here 3 to the power x, so 3 to the power x into limit as x tends to the 0 tan x upon x. And now this is the standard formula. Limit x tends to the 0, a to the power x minus 1 upon x, that is equal to log of a. So the solution of this is log of 3 bracket square, because here a is 3. So log of 3 and bracket square divided by, here limit x tends to the 0, 3 to the power x. So 3 to the power, put here x as 0. So 3 to the power 0, and limit x tends to the 0 tan x upon x, it is standard formula, that is 1. So here it is into 1. So we get here, this is equal to log of 3 bracket square upon 3 to the power 0, anything raised to 0, that is equal to 1. So 1 into this 1. So it is equal to log of 3 bracket square and 1 into 1, that is 1. So denominator always 1, don't write that denominator 1. So solution is log of 3 bracket square. So this is the solution of the first problem. Now see here, second problem, limit x tends to the 0, (3 plus x upon 3 minus x) to the power 1 upon x. Now we have seen formula, limit x tends to the 0, 1 plus x to the power 1 upon x. When there is a power 1 upon x, then always use this formula. Limit x tends to the 0, 1 plus x to the power 1 upon x. Here x upon 1, its a reciprocal is 1 upon x, and this x should tends to 0. This x should tends to 0. Then the value is e. Value is e. Now here, when there is x, here 1, we must have 1 here, but here it is 3. So we want here 1. So divide the numerator by 3 and also denominator by 3. Then we get here 1. When we get here 1, if we divide this 3 by 3, so divide numerator by 3 and also denominator by 3. So this is equal to limit as x tends to the 0. We may write here divide numerator and denominator by 3. So limit as x tends to the 0, 3 upon 3, that is 1, plus x upon 3 and divided by 3 upon 3, 1, minus x upon 3 and whole to the power 1 upon x. So now here it is equal to limit as x tends to the 0. Now we separate this power 1 upon x to numerator and denominator. So we write here 1 plus x upon 3 to the power 1 upon x, and here 1 minus x upon 3 to the power 1 upon x. Means we have to use this formula twice in numerator and denominator. Now separate limit to numerator and denominator, and so we get here limit as x tends to the 0, 1 plus x upon 3, 1 plus x upon 3 to the power 1 upon x, divided by limit as x tends to the 0, 1 minus x upon 3 to the power 1 upon x. We separate the limit. Now here x upon 3, we must have denominator, we must have power as a reciprocal of this. Reciprocal of x upon 3 is 3 upon x. We want here 3 upon x. So we have to adjust here 3 upon x. Here 1 upon x is already given, but we want here 3 upon x. So we have to adjust 3. So we take adjustment like this. Limit as x tends to the 0, 1 plus x upon 3. We want here a reciprocal, here reciprocal of this. So x upon 3 is a reciprocal is 3 upon x. We write directly reciprocal. That is reciprocal of x upon 3 as a 3 upon x. But here power is 1 upon x. Out of that 3 upon x, here 1 upon x is present. Only we adjust 3. So we have to cancel that 3. So take like this square bracket. And here take 1 upon 3, so that this 3 and 3 get cancelled and 1 upon x is here present. And take square bracket like this. So remember here whatever may be the number here, take its reciprocal here directly, and which is given here power, observe that, and other remaining term adjust here. Here x upon 3, its reciprocal is 3 upon x, but out of that 3 upon x, 1 upon x is given, so we adjust only 3, so 3, so we have to cancel this 3, so take here 1 upon 3, so that this product of this is 1 upon x, 3 upon x into 1 upon 3, we take the product using the rule of indices. This 3 and 3 get cancelled, so it is equal to 1 upon x. Okay. Now in the denominator, limit as x tends to the 0. Limit x tends to the 0. In a round bracket, 1 minus x upon 3. 1 minus x upon 3. Directly take its reciprocal minus 3 upon x here, because we have to adjust the formula. Minus x upon 3's reciprocal is minus 3 upon x. Now out of this minus 3 upon x, here 1 upon x is present. So we have to cancel this minus 3. So we write this square bracket and here take minus 1 upon 3. So this minus minus become plus, and 3 and 3 get cancelled, so 1 upon x. So in this way we adjust this. And now here use the standard formula, limit as x tends to the 0, 1 plus x, x reciprocal 1 upon x, here it is e, but here x should tends to 0. Now here as x tends to the 0, as x tends to the 0, we have given x tends to the 0, x upon 3 or minus x upon 3 plus or minus x upon 3, that tends to 0. Because put the value of x as 0, 0 upon 3, that is 0. So when x tends to the 0, x upon 3 also tends to the 0, and using this standard formula, limit x tends to the 0, 1 plus x to the power 1 upon x is equal to e. So this is e, this square bracket is e. So e to the power this 1 upon 3, this square bracket is e. So power here 1 upon 3. Also this square bracket also e, so e to the power this minus 1 upon 3. So it is equal to e to the power 1 upon 3, this 1 upon 3, and carry this power to numerator, this minus become plus. So plus 1 upon 3. So here e to the power, here denominator same, that is 3, and 1 plus 1, that is 2. So e to the power 2 by 3. This is the solution of the second problem. Now we see here third problem. Limit x tends to the 0. Third problem, limit x tends to the 0. 5x plus 3, 5x plus 3 divided by 3 minus 2x, 3 minus 2x to the power 2 upon x, to the power 2 upon x. Here power 1 upon x means we have to use the standard formula, limit x tends to the 0, 1 plus x to the power 1 upon x. So we modify this problem like this, limit as x tends to the 0, right, firstly this 3 plus 5x upon 3 minus 2x and power 2 upon x. Now here we want 1. So divide numerator by 3 and also denominator by 3. Dividing numerator, divide numerator and denominator by 3. And therefore we get here limit as x tends to the 0. Now this 3 upon 3, that is 1, plus 5x upon 3 divided by 3 upon 3, 1, minus 2x divided by 3. Now power is 2 to the power x. Now separate the power 2 to the power x to numerator and denominator and also limit. So it is equal to, we write this as limit x tends to the 0. 1 plus 5x divided by 3 and power here 2 upon x divided by limit x tends to the 0, 1 minus 2x upon 3 to the power 2 upon x. Now here we have to adjust the reciprocal of 5x upon 3 here. Power should be reciprocal of this. 5x upon 3 is the reciprocal is 3 upon 5x. So we must have here 3 upon 5x. We adjust this. So this is equal to limit x tends to the 0. Limit x tends to the 0. 1 plus 5x upon 3. Okay. Now take the reciprocal of this. 5x upon 3's reciprocal is 3 upon 5x. We want here 3 upon 5x. We take. Now see here, power is 2 upon x. Here we have taken 3 upon 5x. Out of that, here 1 upon x is present. 1 upon x is present. And here we adjust 3 upon 5. Okay, we have to cancel this 3 upon 5 means here we take square bracket and then we write here 5 upon 3. This 3 and 3 get cancelled, 5 and 5 get cancelled, 1 upon x. But here 2 upon x. So we want 2. So into here 2. Okay, so 5 2's are 10. So we want here 10 upon 3. Here right here 10 upon 3. See here 3 upon 5x into 10 upon 3. 3 get cancelled. Okay, 5 1's are 5, 5 2's are 10. So 2 upon x. Power here 2 upon x. So we take here 10 upon 3. Take here square bracket like this. Now in the denominator, limit as x tends to the 0, 1 minus 2x upon 3. 1 minus 2x upon 3. Now take the reciprocal of this here. That means here minus 3 upon 2x. Reciprocal of 2x upon 3 is 3 upon 2x. Here minus sign, take here minus sign. Now out of this 3 upon 2x, 3 upon 2x, here 1 upon x is only present, 1 upon x. Here 2 upon x. And here 3 upon 2x. Out of that only 1 upon x present. Here original 2. So write here original 2. Original 2. And we adjust here minus 3 by 2. We have to cancel this minus 3 by 2 by taking minus 2 by 3. So that this 3 and 3 get cancelled, 2 get cancelled, minus get cancelled, and 2 upon x remains. Means we adjust here 2 to the 4, minus 4 upon 3. So we adjust here minus 4 upon 3. And now here we use standard formula. Take square bracket like this. Now since here x tends to the 0, x tends to the 0, this 5x upon 3, 5x upon 3 also tends to the 0. If we put x as 0, 0 into 5, 0 upon 3, that is 0. So 5x upon 3 tends to the 0. Also here minus 2x upon 3, minus 2x upon 3, that also tends to 0. And using standard formula, which standard formula? Limit x tends to the 0, 1 plus x to the power 1 upon x is equal to e. So see here, limit x tends to the 0, 1 plus 5x upon 3. Reciprocal of this is 3 upon 5x. And also this 5x upon 3 tends to the 0, we have written here. So value of this square bracket is e. Similarly, value of this square bracket is e. So it is equal to e to the power 10 upon 3. This square bracket is e and power is 10 upon 3. So here power 10 upon 3 divided by this square bracket is e and power is here minus 4 upon 3. This minus 4 upon 3. Now shift this power in the numerator using the rule of indices, that is a to the power m divided by a to the power n. Here base is same. Here base is same. So it is a to the power m and we carry this n in the numerator. Take minus. So a to the power m minus n. So it is equal to e to the power this 10 upon 3 as it is, and this minus become plus 4 upon 3. So it is equal to e to the power this denominator 3 same, 10 plus 4, that is 14. So e to the power 14 upon 3. This is the final solution. In this way we completed this third problem. Now fourth problem here. Limit x tends to the 0. Limit x tends to the 0. Log of 3 minus x minus log of 3 plus x divided by x. This is the fourth problem. Limit x tends to the 0. Log of 3 minus x minus log of 3 plus x upon x. So solution of this is equal to limit as x tends to the 0. Limit as x tends to the 0. We write this divided by x as 1 upon x. And take here log common. So if we take log common, we get log of 3 minus x upon 3 plus x. When there is a subtraction, we divide. So log of 3 minus x upon 3 plus x. Now this 1 upon x, we take the power of this using the rules of logarithm, that is m into log of a, that is equal to log of a to the power m. This is the formula. So it is equal to limit as x tends to the 0 log of 3 minus x upon 3 plus x to the power 1 upon x. Again here power 1 upon x. So here should be 1. 1 minus x or 1 plus x. But here 3. So divide this numerator by 3 and also denominator by 3. 3 divided by 3, 1. Here also 3 divided by 3, 1. So divide numerator and denominator by 3. And now here take this log outside the limit. So we get here log of limit as x tends to the 0. 3 upon 3, that is 1, minus x upon 3 divided by here 3 upon 3, 1, plus here x upon 3, and power is here 1 upon x. Now we separate the power to numerator and denominator and also limit. So this is equal to log of limit as x tends to the 0, 1 minus x upon 3 to the power 1 upon x, and limit as x tends to the 0, 1 plus x upon 3 to the power 1 upon x. Now here adjust the reciprocal as before example we have seen. So log as it is. So it is equal to log of, in the numerator, limit as x tends to the 0, 1 minus x upon 3. 1 minus x upon 3. Here 1 minus x upon 3. Take the reciprocal of minus x upon 3 as a minus 3 upon x directly to adjust the formula, to use the formula. Minus x upon 3's reciprocal is minus 3 upon x, but here power is 1 upon x. Out of that minus 3 upon x, here 1 upon x is present. Only we adjust this minus 3. So cancel that minus 3 by taking minus 1 upon 3. This 3 and 3 get cancelled while we take the multiplication. And take square bracket from this. Now in the denominator, limit as x tends to the 0, 1 plus here x upon 3. 1 plus x upon 3. Directly take the reciprocal of this, that is 3 upon x. But here 1 upon x is present. So we have to adjust only 3. So right here 1 upon 3. If we take the product of these two, we get 1 upon x. 1 upon x. So now here we have to use standard formula. Before that, here x by 3 should tends to the 0, plus x by 3 also tends to the 0. Now since here x tends to the 0, this plus x by 3, here this plus x by 3 or minus x by 3 tends to the 0. And using here standard formula, limit x tends to the 0, 1 plus x to the power 1 upon x is equal to e. Always write this. So value of this square bracket is e. Write this log as it is. And here numerator is e to the power minus 1 upon 3 divided by denominator, here this is e. So e to the power this 1 upon 3. Now carry this e to the power 1 upon 3 in the numerator, and therefore we get here log of e to the power this minus 1 upon 3 as it is. This plus become minus, so minus 1 upon 3. Okay, so we get here log of e to the power, here denominator 3, here 3, so write 3, and this minus 1 and minus 1, that is minus 2 upon 3. So log of e to the power minus 2 upon 3. We write here using the rules of logarithm, take this minus 2 by 3 as a coefficient. This power take as a coefficient. So here it is minus 2 upon 3 into log of e. So this is equal to minus 2 upon 3 as it is, and we know that log of e is 1. Log of e here it is 1. So minus 2 by 3 into 1, it is equal to minus 2 by 3. This is the solution. So in this way we completed fourth problem. Now fifth problem. Limit x tends to the 0. Limit x tends to the 0. 4x plus 1. 4x plus 1 divided by 1 minus 4x. 1 minus 4x to the power 1 upon x. Now see, in the numerator 4x plus 1, here 1 minus 4x. We write here 1 firstly and then 4x, that is 1 plus 4x. So it is equal to limit as x tends to the 0. Here write 1 firstly and then 4x. 1 plus 4x divided by 1 minus 4x to the power 1 upon x. Now separate the power 1 upon x to numerator and denominator with limit. So this is equal to limit as x tends to the 0, 1 plus 4x to the power 1 upon x, and here also limit as x tends to the 0, 1 minus 4x to the power 1 upon x. Here power 1 upon x, we know which formula we have to use. We take the reciprocal of this 4x here. So in the next step, limit as x tends to the 0. Here also limit as x tends to the 0. So here 1 plus 4x as it is. Take the reciprocal of this 4x as 1 upon 4x directly. Firstly write the reciprocal of this term here directly, and see here out of this which is present here. Means here we take 1 upon 4x, and out of that here 1 upon x is present. Only we adjust here 4, 1 upon 4. Okay, we have to cancel this 1 upon 4. So we take here 4. So this 4 and 4 get cancelled. So here 1 upon x, which is here. So, and in the denominator also, here 1 minus 4x, 1 minus 4x. Directly take the reciprocal of this minus 4x as minus 1 upon 4x. Minus 1 upon 4x. And now see here, out of this minus 1 upon 4x, which term is present here? Only 1 upon x is present. So we have to cancel this 4 with minus sign. So we take here minus 4. We take here minus 4. This 4 get cancelled, minus become plus. And here take square bracket. And now here, as x tends to the 0, this 4x also tends to the 0. We have to use standard formula. In standard formula, here x, here 1 upon x, then the value is e. So we have to must here 4x tends to the 0, also minus 4x tends to the 0. So write that reason here, since x tends to the 0, 4x also tends to the 0, and minus 4x also tends to the 0. Plus 4x and minus 4x tends to the 0. And using the standard formula, limit x tends to the 0, 1 plus x to the power 1 upon x, that is equal to e. And therefore here the value of this square bracket in the numerator is e. So it is equal to e to the power 4 divided by, here also this is e to the power this minus 4. Now carry this minus 4 in the numerator, and therefore we get here e to the power 4, this minus become plus 4. So it is equal to e to the power 4 plus 4, 8. So this is the fifth problem. Now the last problem in this question, question number 2, last problem, limit x tends to the 0. Sixth problem, limit x tends to the 0 5 plus 7x, 5 plus 7x divided by 5 minus 3x, 5 minus 3x to the power 1 upon 3x. So when there is a power 1 upon, at that time we have to use the formula limit x tends to the 0, power 1 upon x, here 1 plus x, and formula is here e. So here 1 upon 3x we use that formula, but here in the bracket 1 plus x, we must have 1 plus x, but here 5 is given, here 5, here 5. So when here 1 comes, if we divide this by 5, 5 by 5, 1, here 5 by 5, 1, means divide numerator and denominator by 5. Divide numerator and denominator by 5, and therefore we get here limit as x tends to the 0, 5 divided by 5, 1, plus 7x divided by 5, that is 7x upon 5, in the denominator 5 divided by 5, 1, minus 3x divided by 5, 3x upon 5, and here power is 1 upon 3x. Now we separate this power 1 upon 3x to this numerator and denominator with limit. So it is equal to limit as x tends to the 0, limit x tends to the 0, 1 plus 7x upon 5 to the power 1 upon 3x, and divided by limit x tends to the 0, 1 minus 3x divided by 5 to the power 1 upon 3x. Now we have to adjust the reciprocal of this as a power. Here also reciprocal of this as a power. So limit as x tends to the 0 in the numerator, limit x tends to the 0 in round bracket 1 plus 7x upon 5, 1 plus 7x upon 5. We want the reciprocal of this as a power, so take directly reciprocal. 7x upon 5 is reciprocal, 5 upon 7x, get it, 5 upon 7x. Out of that, here only 1 upon x is present, only 1 upon x is present. Originally here 1 upon 3, so we have to take here originally 1 upon 3, okay. Here original 1 upon 3, we take original 1 upon 3 as it is, and 1 upon x is here. Now we adjust here 5 upon 7, we have to cancel that, so we take here 7 upon 5, so that 7 get cancelled, 5 get cancelled, means here we take 1 into 7, that is 7 upon 15. So here we take directly 7 upon 15, okay. Now in the denominator, write this square bracket here. In the denominator, limit as x tends to the 0, here 1 minus 3x upon 5, 1 minus 3x upon 5. Now take the reciprocal of minus 3x upon 5 as minus 5 upon 3x here directly. Means here denominator become numerator and numerator become denominator. This is the reciprocal, we know. Now out of this minus 5 upon 3x, here 1 upon 3x is present. Means this is present, 1 upon 3x is present. Only we adjust minus 5. We have to cancel that minus 5 by taking here minus 1 upon 5. Minus 1 upon 5. Here 5 is in the multiplication. So divide here 5. Minus minus become plus. Okay. So now here we have to write reason. Since here x tends to 0. X tends to the 0. This 7x upon 5. 7x upon 5 also tends to 0. Put here x 0. 0 into 7. 0. 0 upon 5, that is 0. So 7x upon 5 tends to the 0. Also this minus 3x upon 5. Minus 3x upon 5 also tends to 0. And using here standard formula, limit x tends to the 0, 1 plus x to the power 1 upon x, it is equal to e. So the value of this square bracket is e. So e to the power this 7 upon 15 divided by this square bracket is e and power here minus 1 upon 5. Okay, now carry this power minus 1 upon 5 in the numerator. So it is equal to e to the power this 7 upon 15. Okay, this minus become plus, so plus 1 upon 15. Now we have to take the addition, denominator should be same, so denominator should be 15. So it is equal to e to the power, denominator should be 15. So here 15 present, so 7 as it is, but here there is only 5, we want 15, so multiply by 3, so 5 into 3 15. Similarly multiply by 3 to numerator, 1 into 3 that is 3, and 3 plus 7 that is 10, so it is 10 upon 15. Now this 10 upon 15 divided by 5, 5 2s are 10 and 5 3s are 15, so e to the power 2 upon 3, this is the solution for this problem. So in this way we completed 6th problem and question number 2nd also completed. Now here in the exercise 7.6 only question number 3 is remaining. We will see that question number 3 in the next video lecture. Okay, we stop here.